Now I'll talk about the wiring system of the project we do. So basically we use two types of boards for the wiring connection, which is the circuit board and the breadboard. So basically on the circuit board, we connect the wiring of the solenoid and the relay, while for the breadboard we connect the wiring of the sensor, which is the proximity sensor, and the temperature and humidity sensor, and one more is a switch. So all of the ground from the valve, the relay, and the sensor and the switch is connected to the breadboard, and it is directed with one wire to the ground port of the Raspberry Pi. So one more wire is directed to the negative terminal of the power supply. Okay, so for the positive port, it is connected to the interconnect, and all of the live wire of the valve and the sensor is connected, and also the switch. Here's some rough explanation about the coding, which includes the languages and the meanings. First, before we start, to write our main program, we need to include all the library modules. These are all the packages that need to be included, especially the Raspberry Pi GPIO package and the time module. After that, we declare the variables by assigning different GPIO port to them. For example, GPIO 17 for black switch and GPIO 27 for proximity sensor A. We also need to define the version of GPIO headers. Next, we will assign the pin setup, which is either input pin or output pin. The switch and sensor will act as input as they receive signal, while the relay and valve is the output where they perform the movement. Then, we set the initial state of valve and relay. It should be noted that not all the sets have the same pneumatic valve, and hence they will have different settings. We also use magnetic sensor to determine the existence of valve, and the humidity sensor to determine the humidity level and temperature inside the room. Going into the loop, when the black switch is pressed, the relay A, which moves from left to right, will be activated. The conveyor belt will move to carry the box to move to right. When proximity sensor A senses the metal on the box, the conveyor belt will stop. The system will perform 2 sets of cylinder movement, and 2 ping pong balls will be collected according to the sequence of cylinder movement. Then, the conveyor belt will continue to move to the right until the proximity sensor B senses the metal. The same cylinder movement and ball collecting will take place. After 4 balls are being collected, or to be more accurate, 4 sets of cylinder movement is being performed, the relay B is set high, so that the conveyor belt will change direction and move to the left. And when the metal again activates the sensor A. The cylinder movement allows 2 more ping pong balls to be collected. Then, the conveyor belt will move to the right, and 2 more ping pong balls will be collected when the sensor B senses the metal. After performing X set of cylinder movement, cylinder belt will move to the right for 2 seconds, and relay A is set to low. The conveyor belt will stop, and all the GPIO pin is cleaned up. Note that this action will reset all the ports that have been used in this program back to the input mode. This prevents damage from, let's say, a situation where you have a port set high as an output and you accidentally connect it to the ground, which would short circuit the port and possibly spoil it. It's safer to leave ports as inputs as they can handle either 0 volt or 3.3 volt.